So this is a kind of unusual study in forestry. We're looking for a dead tree, but we're not doing really something for inventory, even though applications of that could be possible, in which case you would then deal with probability and whatnot. We're looking pretty much for, as you could call it, forensic analysis and forensic evidence in a case of looking for a tree that had been broken. It's a special tree, but first about the team, we have a number of people who are certified in various areas, very experienced in photogrammetric analysis and very experienced in various GIS analysis, as well as image processing and image computer recognition and whatnot. So the study has been replicated several times. I'll give you a very kind of short version of it, just in case you would like a contingency plan of leaving earlier. After this slide, you pretty much know everything. Just after that, I'll go through details for those who are interested in some logistics and some technical methods that we use. So generally, the story is that there is a famous tree out there that it's officially declared by two governments and various scientists to do something that other scientists believe is impossible. And they believe it's impossible on various grounds: aerodynamics analysis, laws of physics, general knowledge of available technology and whatnot. There's about 110 scientists in so-called Smoleńsk conference, most of them professors and PhDs and whatnot, that throwing a conference that is going to have a second run in 10 days. That's where this, originally this presentation was supposed to be presented. Then, at the same time, two government committees, aviation specialists and whatnot, were not able to find that tree on the satellite imagery and published wrong coordinates, so you couldn't really find it. We had to kind of do investigation of where it was. Then, using various data, sort of enhancing the understanding where to look for what and what it's going to look like, we were able to locate it and then later look at different times from satellite imageries that were available for different dates. And we found that basically, after finding the exact location of it, we found that the tree was actually broken 5 days before the whole incident and the whole international dispute on the subject was pertaining to it. So, this is the tree. It's a sort of a monument. I showed you kind of a compilation, roughly what it would look like, where it would be located on the satellite imagery. This is not meaningful at this point. I'm just kind of trying to with your imagination. This cross, by the way, it's one of the fundamental sort of keys to our investigation, because we used it for measuring everything else from it. At knowing the dimensions of that cross, and that cross is on every single picture, there are not hundreds, but possibly, yeah, well, hundreds of the tree and thousands of the trees from that whole incident available. This is what happened. This is what's special about it. The tree is said to break a wing of a 100-ton plane. It's a, we call it 154M. It's a replica of Boeing 727. 40 meters about span of that wing and, sorry, of its wings. It's a big commercial plane. The tree had about 40 centimeters diameter at the height of, allegedly, according to Russian Aviation Investigation Committee, 5.1 meter height, according to Polish prosecutors, depending on the dates, varying from 5 to 9 meters, 7.7. They couldn't quite make up their mind about it, but they were changing it. The last measurement, I think, was 6.6. So, who argues? Well, as institutionally, MAC is the Russian Investigative Committee. The Miller report is a Polish investigative committee. That's two governments, one of the biggest country in the world. Polish Congressional Committee questioning the legitimacy or the accuracy of the other two. University of Akron, it's a Professor Bienda is a Dean of Aerodynamics Department, Engineering Department in the University of Akron. He's a sort of lead investigator. Smoleńskiej Conference, it's an organization of mostly professors from different countries, universities, and other independent scientists. That I'm one of them. I'm currently involved with that Smoleńskiej Conference, but I don't represent any of the political formations or governments or the congressional part, even though last year a congressman, Antoni Macierewicz, came to our school to thank us for our study that we did relating to it, which was basically just finding a density of that tree based on the comparison of, say, kinetic energy generated by that plane is about 6 orders of magnitude greater than the shear resistance of the birch wood. But the government side were claiming that that birch was incredibly strong. It was a special birch. And we got a piece of that tree from branch and did a study on Sylvie scan and infra spectroscopy and all kind of basically state of the art. We analyzed the hell out of that tree and got like 10,500 of measurements with a resolution of 25 microns. And found that it was not very exciting, that birch tree was made basically of an average birch wood. And it was having just quite regular density, pretty much ordinary the tables. And that fed into the studies of Professor Bienda, and after that I was called in the Polish newspapers a hyena feeding on the tragedy of the people who died there and so on, and liar and whatnot. Not in relation to that 550 kilograms per cubic meter that we came up with, but on just, I guess, general attitude. So I still refuse to be any part of any politics, but the science of it is quite interesting when you start looking at right now the satellite imagery. The thing that prompted us to look into it was not even the multitude of arguments that probably would convince anybody with engineering background, like for example the fact that the tree, like you said, the kinetic energy generated by the plane is 6 orders of magnitude greater than the resistance of that tree. But just from a forester point of view, being familiar with the wood, working a lot in the wood, I have my first encounter with the birch when I actually cut it myself was in 1972, which is quite a long time ago. We're collecting juices from that. That's a silver birch, but Betula vericosa. It generates a very friendly juice, a kind of sweet water. Is good for your hair, for drinking, for skin, for anything. And as kids, we were playing with it quite a lot. So a birch that gets cut, that species, generates a lot of juices. So this is an example on that. And the first thing that hit me after already, I was seeing this violent reaction to our discovery that this was an ordinary birch. Was that it didn't have any juices. When you look at that break, this picture was taken 2 days after that on the 13th, and it looks completely dry. That's atypical for it. Another thing is the dynamic break of the plane was flying 80 meters per second. That's about a few nanoseconds contact with that birch. That's like a bullet hitting the wood. So if you look at it here, you've got those knots there. And they're basically extracted. They're not cut. They should be cut. They should be sheared. You see a little branches there. If the wing were even completely broken off, unless it would be made out of styrofoam, it would shave them clean. If anything like splinters and so on, in a dynamic cut, you get them basically shattered get extracted outside. If you think of a bullet hitting anything, it's a small hole that it cuts in from the entranceway, and on the outside is a big just open. There are no splinters, there are no kind of hanging pieces of it. So that's just like from the first point of view. Seeing this, it was intriguing that this tree just didn't make sense. It was looking the way it was. Aside from the fact that there were trees right behind it, and that the plane would have to raise from 5 meters to 20 about to clear them in about a fraction of a second, about a quarter of a second, which exceeds the parameters of any known military plane, including the ones in the Men of Black and the Men in Black. Sorry. Well, when you study this thing, then you can appreciate that Men in Black, because it kind of makes you aware of these aliens among us that can make things that we don't understand, which are part of those Russian and Polish reports. So anyhow, in short, the break looked like a red herring. Red herring, by the way, for those who don't know from this, it's a sort of detraction from the topic, something that means to really detract from what the real issue is. And it didn't look like a result of neither dynamic break, which is something that will happen in a few nanoseconds of the contact, which we're talking about all these things like shaved, sheared, shattered, as opposed to just broken. Nor it looked like it was on April 10, which is would have the juices and would look more fresh and whatnot. But that's of course not the proof. So we started looking into various data. The data we looked at were satellite imagery available, so-called high resolution, so 50 centimeters. And well, as the best we could do, there was some on Google Earth. We purchased some directly from Global Digital. Actually, we bought it from Apollo Mapping. They have better prices, but that's the reseller vendor is Global Digital. So then other data, because with the satellite imagery and with the documentation and the government reports and so on, there was just no way to find that tree. And other data that we used were from a footage of a documentary movie and from various ground photography that part of was a sort of a private contribution of a private person, and part of it was available pictures available on the internet and so on. And yeah, I can show you actually. That's, by the way, just the example of that. Part of the dispute where Professor Binienda is a keynote speaker at the engineering conference in California, and talks about that very issue, the impossibility of what is reported as what happened. Here is a example of that particular. That's only takes about half a minute. So this is the tree. That's the documentary that we took some screenshots from that used as data. This shows a flight over it. That's what allowed us to actually see where that tree was. Indeed, otherwise there was really no way to see it from the ground photography. So it shows here next to the trailer. That trailer is a landmark, and the distance of everything else basically was what we use as a relational sort of relative information or distances to where to look for it. And it's going to fly right back and show it again from another angle. And after that, I'll stop it. So this is not a bad, we did get permission to use it. That's what you saw there. This here. See right ahead there are these trees that are much bigger. That's where I was talking that in a quarter second I saw the plane would have to jump 20 meters and so. There's a little more of a shot, but it doesn't matter. This is, let's just kill that thing and I'll go on with my presentation. So these are the part of the data That's what helped us to find. Now, so the next thing is what are we looking for? I mean, this is a so-called high-resolution imagery, high meter. It's not something that's going to show you branches and leaves and possibly allow you to show the species. So basically, what in order to kind of demonstrate or illustrate to everybody what we're looking for, we generated a simulated pixelization of the image. You can see the actual picture over it is clearly the panchromatic. Here it's pixelized to about approximately that resolution, half a meter. That's what you see, and you see that unless you know what you're looking for, there's no hope that you can actually find anything meaningful there. So based on that developed geometry and the place that you're looking for, that you know what you're looking for, you know what the expectation is, that you will not see anything that is much less than half a meter. But if the distance between, say, a wider thing is like in the range of a meter and the length of it is in the range of a few meters, then you're going to see that signal. But how that's going to appear on the picture in terms of configuration, the actual pixels, is going to depend on various things. So each of the images, the satellite images, had different angle of the sensor to the ground. It had, of course, different light conditions at the time when it was taken, and so on. So one example of which you're looking at approximately 4 is this. The tree is actually here, but you can't know it unless you actually do know where it is. So this is what you look for. This is your area of, this is your zone or polygon of examination, and it becomes unambiguous because if the tree is not broken, there is nothing white, no reflection, and you get something somewhere here, you don't even have to know where it is if you know it's not there. But here, it could be anywhere, and if you see it here, then you can conclusively say that you found it, that the tree was there, unless somebody painted that area, which probably will be the case of the official news after this presentation gets around, or something along that lines. So the exact location is the key. So, well, of course, we go to the exact location, and here's the biggest country in the world government location. Here's the, maybe not the smallest, but Polish, whatever, government location. Here's the Wikipedia location. All of this tree. And there's no tree really where to find it. Well, you could speculate maybe this was the tree. Actually, originally one of the people that we were working with before we actually knew the location was arguing that this was the tree. You can clearly see the branches and stuff. And so you cannot see the branches. If you see the branches, that means you're wrong. You're interpreting something wrong, because the branches will not be recorded on the half a meter pixels. So that's the main thing. You cannot look for branches. You're looking for something else. Well, so there is no tree here, no tree here, no tree. What you have there, though, is like pictures. You've got all kind of information out there about this, but not location. So then we go farther and we start looking at that aerial photography, and we find where the tree is in relation to various constructs, buildings, roads, intersections, and so on. And from that, then in a combination of those distances, we basically sort of map it on the satellite imagery location. Then we did all kind of analysis. I cannot tell you even everything we did, because that whole investigation process was changing as we were understanding about more about the size. It appeared that probably 100 measurements that we did earlier were absolutely unnecessary. It's just all you need is one measurement really, which is a distance from that stump to the corner of that trail. But originally, there's all kind of angles and different zones, so we really have to know where it is exactly. So in order to get that distance, and here's the cross and so on, we did that on various ground photographs. And so you know the distance exactly here, and then you basically work out all the other distance. It came out to be, depending on a slight difference in the angle distance from the focal length and whatnot, it was about between 10 and 11 meters. with the gas 10.5 meters in the corner. So, with all this kind of, this is one of the earlier slides, shows all kind of unnecessary additional weights and measurements and so on. What really, in the end, was the most useful, the most practical, was the geometry, building a map geometry. These are perpendicular directions. 6 by 12 meters basically encompasses that. If you cut off that on diagonal, you're ending up with this, from half to half of that, and there gives you the zone of the main ball. The part of it by the on the top of it could possibly be the branches, but does not have to be. We really are looking just for the main part of the term. So you go then from again, just reiteration of what I just said, paraglide ground photography, mapping from vertical projection, going to satellite, creating a template, moving it between different images. So the first result, good achievement, I guess, given that the Russian government was incapable of getting it, and the Polish government was incapable of getting it, and the whole world Wikipedia editors couldn't. We got the exact coordinates of the tree, we defined where it is, gave it in all kind of ways to find it, from the distances to landmarks, from the distances to the actual other reported coordinates, and the trailer and so on. Well, now it's then to go into the actual investigation of that tree. So that's what the satellite imagery looks like, and the trailer is a kind of saving grace, because that's the only thing that you can really see here, unambiguous. So this is the trailer. I guess if you don't see it yet, well, stare at it long enough, you'll see soon enough. It's really at one point when you're watching all these images for a few hours and so on, it starts popping at you, and you really can see it in a sleep, even when you fall asleep. So this is in the January picture. That's when the tree was not broken. The trailer is still the same, and basically these three images here, those two and this one, they mark the zone of agreement. Everybody in the world, Russians, Polish, whatever, they all agree that the trailer was there, the tree was not there, not broken here, and it was broken there. So there's no ambiguity here. We're looking for something that everybody agrees on, and there's no particular point of either discovery or disagreement or anything really earth-shaking. So again, this is in relation. Normally we would be looking Russian coordinates, Polish coordinates, Wikipedia coordinates. We really should be looking here, our coordinates. And that's the same, basically, the other way definition in terms of the angles and the distances where we should be looking for the tree. So that's what we're finding out. Second result is the actual confirmation of existence. Everybody knows where it is. This is our tree. This is the close-up zoom, basically. Unless they painted it, well, they didn't. Everybody agrees the tree was there. So that's the tree. That's the main ball. This part potentially could be the branches, but they're really either here or there, because that's the stump and that's the main ball. And here is the ground. We don't see anything white, no reflection, no broken stump, no white bark or the birds flying down. So now is the big question. What was it on April 5? 5 days before the marvelous things happened that everybody argues about. And that's what it is. So now we're looking at this. And that's the satellite imagery. And by the way, contrary to everything else presented on this conference here, we didn't do any outliers, we didn't do any kind of data cleaning, we didn't do anything with the data. We just took the data the way it was. It's represented the way that the images came to us. The only thing we did was auto-rectification. We auto-rectified everything to a common place so that we can apply this kind of template there. And everything was auto-rectified to the Bing image, because that was the only image that had a high reputation, sort of, in terms of reliability of the auto-rectification. the Google images don't agree with themselves, the trailer is moving all over if you go from 11s to the 12s and so on. So in the end, the first approach was that we should do it to Google because everybody can use Google and so on. Later, the expertise was that no, this is not professional enough, it's not reliable enough, so we did it to Bing. But otherwise than that, this is what the raw data is, and the question is here. Does this belong to this population, or does this belong to this population? Well, I guess George Bush had the perfect answer for that one. This was going something like, read my lips. But basically, this was a stunning result. It explains pretty much everything about the juices and the cut and whatnot. At the same time, you have to realize that this is what everybody agrees on, this is what everybody agrees on. This goes against everybody. I mean, everybody, even those who were arguing that the thing was impossible, were assuming that the tree was there. So the question, well, that changes the whole face of the argument, but that's not the end of the story. What you're looking at here is that the time series changes in what happened. The stump of that tree, it's under angle, and it's about over a meter off the center. So the top of it is about a meter off the center. So you're having here a sort of the snag standing like that, and a broken top that is about twice as long as the snag, and it's sliding down with time. And here it looks like it's right on top of it. Here it is a little farther, and here is a farther yet, and here is farther still. And that's all perfectly fine. And I mean, that's you know, gravity and everything, and evidently somebody was climbing on this thing there, because at one point there were some pictures showing that parts of the plane were embedded into it, and at another point they weren't there, and it's so, you know, even if the plane put the pieces there, then somebody climbed in to take them out. Well, unless of course it was a Photoshop work, and in that case the climbing maybe wasn't necessary. But that's a kind of interesting additional information that we didn't even expect to get, is that this thing seemed to be right on top of that stump, which means that likely it would have been broken right about that time. So possibly on the 4th, maybe a couple of days earlier, but very, very close to it. Plus, there's a little more of a reflection around the stump, which potentially could be the juices. So that's kind of interesting, unexpected kind of bonus on that. I'm not sure it makes perfect sense in terms of rationalization of what we're seeing here, but that is really not what we're looking for, and it's either here or there, but it's an interesting thing to know that this happened. So the conclusion, well, the conclusion is basically that, and it was replicated many times, it was done by very competent people, and it was, and I'm not, don't mean even me, we had, when we were up to it, we started looking around for, you know, I'm not even going to go by myself and say that I found that. We started looking at the most competent people we could find anywhere we knew. And we got some. I mean, Margaret Madden and Thomas Jordan are basically, you know, as good as it gets in this area, and with experience with forensic analysis and sworn testimonies, and in the past work in this area and compare meticulous and so on. And basically, from what we found, the information or the finding that the tree was broken on the 5th is a fact, and the fact is undisputable. And you may ask, is it possible that we went wrong something, we did something wrong? Well, I would say theoretically it's possible, but practically it's not. Or I would put it maybe this way, that theoretically it's possible, but the probability of it is 0, which means that it might have happened, but it's infinitely unlikely. So basically, it's kind of, you know, like you think of a perfect ball, you drop it on a perfect surface, and any point you say it will stop on, its probability of stopping there is 0. But it stops on some kind of point, always, right? So it is possible, but I think it's absolutely unlikely. So then, what's the expectation was going to happen? Well, I thought that was a really fantastic news that everybody's going to say, oh, you know, how stupid of me, you know, made a mistake. Then let's look for what it really was. But I've been told that it's going to happen something different. That they're going to find witnesses who saw that tree actually being not broken on the 5th and in fact on the 9th, and that the Pravda, which is called, which is the Russian newspaper in English translation, the Truth, will publish the truth about all these witnesses, and you know, the Polish newspapers will repeat that and so on. So probably it's not the end of the story. And,